So if I have two functions here, f of x equals the square root of x plus 2, and g of x is the cubed root of x minus 1, I want to find some function values. And this is something that we learned how to do in 3.6. So for a, f of 7 means I'm going to take the f of x function, and instead of x, I put 7. So the square root of 7 plus 2 is the square root of 9. And since 9 is 3 times 3, the square root is 3. So f of 7 equals 3. For b, I want to find g of 9, so I'm going to use the g of x function, the cubed root of x minus 1. And x is 9 here, so 9 minus 1 is 8. And the cubed root of 8 is 2, we found from the previous video there. So g of 9 equals 2. Then lastly, f of 0, so we're going to be using f again, which is the square root of x plus 2. So we put 0 in for x, and 0 plus 2 is 2, which can't be simplified because it is an irrational number, so I'm just going to leave it as the square root of 2. So f of 0 equals the square root of 2. Now, the question is, what is the domain of the function f? So since the function f is a square root function, remember it's not defined anywhere less than 0, like the square root of -1. That's not real, so we don't include it as part of our domain. So the domain is going to be what's in the radicand, such that it's greater than or equal to 0. 0 is fine because the square root of 0 is 0, and that is defined. But if we subtract 2, we find that when x is anything greater than or equal to -2, that's part of the domain, and anything other than that is not in the domain. So you can write that as an interval from -infinity to -2, and from -2 to positive infinity. That's the domain of the function f. Now if we look at the function g, it's the cubed root function. And remember, the cubed root function is defined everywhere. We don't need to restrict the radicand. And so this is going to have a domain of all real numbers from -infinity to positive infinity. And if we were to graph the square root function, remember that looks like a point that goes up. That's the square root of x, where it starts at the origin. That's the basic function. So if I were to graph g of x, which is the square root of x minus 1, what would that look like? I just want a rough graph here. So we can use a transformation like we learned in 8.3. And that is if you have adding or subtracting inside that basic square root function. So inside, that's going to be a horizontal shift. And it does the opposite of what you think it does. So no, it doesn't go left, it goes right 1 unit. So we'll go to the right. Instead of 0, 0, we'll be at 1, 0 for our starting point, and it looks like that. Now the cubed root function we haven't graphed yet. So what we could do with the cubed root function is you can create a table of ordered pairs if you want, of x and y, or x and h of x. So the cubed root is defined anywhere, but I want to have some perfect cubes to put in for x, right? So how about 8 as a negative and a positive, 0 of course. What about 1? It doesn't matter if these are out of order. And that should do it. Let's see how that looks. So let's start with -8. If we were to put that into the function here for x, then the cubed root of -8 is -2, plus 2 is 0. So h of 0 is cubed root of 0 plus 2, so 0 plus 2 is 2. If we were to look at the positive 8, how is that going to change? Well, it's not going to be a -2 here. For the cubed root of 8, it's going to be a positive 2, so 2 plus 2 is 4. And if we were looking at -1, the cubed root of -1 is -1, plus 2 is 1. And if this were a positive 1, then the cubed root of 1 would be 1 plus 2, which is 3. Okay, so let's check these out and graph them. So -8, 0. Might as well get some. I thought I was going to do a rough graph, which probably could because I know what this looks like, but I want to give a good idea here. So 1, 2, 3, 4, 5, 6, 7, 8, 4. -1, 1, and 1, 3. Okay, that's a good idea of what this looks like. So we've got a curve here that kind of switches the way that it's curving. Oops, too much that way. Let's go this way, and it keeps going this way. So the cubed root function looks like this shape here. And the middle is generally 0, 0 for just a regular basic cubed root. Like f of x equals cubed root of x. It will go through the origin, just like all basic functions. So this function you can see had a shift up to. That's why it goes through the point 0, 2 here instead of 0, 0.